today we're going to be talking about trapezoids and types of trapezoids. Okay, so let's get started. So this is a trapezoid, but why? In other words, what makes a trapezoid a trapezoid? Well, first of all, it has to be a quadrilateral, which is a four-sided shape. But not just any four-sided shape, it has to have, really importantly, one set of parallel sides that are indicated by this little arrow thingy here. And if there's another set of parallel sides, two arrows, and so on. It's like the congruent slash thingy. Tick. Yeah. Okay, so that means there can be a lot more trapezoids that aren't this classic one. Let's look at a few examples. Like this. If these two sides are parallel, that means that, yes, this is a trapezoid. At least they're supposed to be parallel. And this is a trapezoid because these two sides are parallel. Again, indicated by these little arrow thingies. Okay, you know what? Let's get into the specifics. Let's look at a few types of trapezoids. A couple, actually. First, we'll look at isosceles trapezoids. This is an isosceles trapezoid. It's the first trapezoid that we looked at, the classic trapezoid. It's covering our brains on top. Let's move it out of the way. Okay, why is it called an isosceles trapezoid? Because the two legs, the sides that aren't the parallel sides, are congruent to each other. Like isosceles triangle, the two legs are congruent. Yeah. And why is this so special? We'll look at a few features. Like in isosceles triangles, if you want to learn more about isosceles triangles, check out the link in the description. They're really interesting. But the base angles are congruent. These two base angles, because this is a base right here, but this is also a base, so hence these two base angles are also congruent. And the diagonals of this trapezoid are also congruent. And if you look at it, the opposite angles are supplementary. See, they add up nicely, make a nice line. Also, these two adjacent angles, but not these. So that's why it's just opposite angles, because that works every time. Okay. What else happens here? Well, look at this. This is pretty interesting. If you draw a height from this vertex right here, right? And let's give a few labels. Let's call base 1 A and base 2 B. So A and B, it's easier. The distance from this corner to the where the height intercepts A is actually the length A minus B over 2. And this part from here to here is actually A plus B over 2. And the really interesting thing about that is that this right here is the average of both bases. And if you remember from the area of the trapezoids video, if you haven't watched that, check out the link in the description. But the formula for the area of trapezoid is A plus B over 2 times height, or base 1 plus base 2 over 2 times height. Okay, this times the height. So that means this times the height in an isosceles trapezoid should be equal to the area, and we can prove that. Clear the stage a bit. And we can just take this triangle and move it over there and do a little flipping. And we have a rectangle that's A plus B over 2 times height, which is the area we just moved apart, right? That's isosceles trapezoids in a nutshell. Next, let's look at right trapezoids. Right trapezoid is just a trapezoid that has two adjacent right angles, just like the third example that we saw. This. Yep. So, let's give it a few labels, because right trapezoids aren't more like feature like the isosceles trapezoid, but they have a lot of formulas. So, well, let's call this side A and this side B. Yep. The longer diagonal D sub 1, the shorter diagonal D sub 2. This side, which is called the oblique side, S, we'll call this part right here called the oblique side projection, C, and then the height is H. Okay. Our first set of formulas is this. So capital A is area. So area equals A plus B times H over 2. We already know that. But from that, if we manipulate this equation, we get A plus B equals 2 times the area over H. And that H equals 2 times the area over A plus B. And from the second equation, you could subtract B and subtract A to get base 1 and base 2. Yeah. Okay. Let's look at our next set of formulas, equations. Okay, C equals A minus B. So this equals this whole thing minus this thing. Makes sense. And we have A equals B plus C. Basically the reverse of this. Also makes sense. And B equals A minus C. Again, though, but pretty much the same thing. Okay. A, B, and C. Okay. Those are pretty simple. The next few are dealing with the Pythagorean theorem because you can see a lot of right triangles. In this case, we have this right triangle right here, right? Since S is the hypotenuse, that means this squared plus this squared has to equal this squared. So if you take the square root of both sides, that's where you get this. And if you want to learn more about right triangles and the Pythagorean theorem, check out the link in the description. Thumbs down. Yeah, you know what I mean. That means S equals the square root of C squared plus H squared. And using the same thing, C equals the square root of S squared minus H squared. And H equals the square root of S squared minus C squared. Okay. This next set is also based on the Pythagorean theorem. D sub 1, in this case the hypotenuse, equals A squared plus H squared. The next one is A equals the square root of D sub 1 squared minus H squared. And H equals the square root of D sub 1 squared minus A squared. Makes sense again. In this case, it's this right triangle. And next set, we have D sub 2 equals the square root of B squared plus H squared. Yeah, makes sense. And we have B equals the square root of D sub 2 squared minus H squared. Yes, makes sense. H equals the square root of D sub 2 squared minus B squared. Yep. So those are all our formulas, all my formulas. Yeah, whatever. Yeah, but if you want to see where I got these formulas from, I'll leave a link for that to that website in the description. Cause yeah. Okay. Let's go on. We have one more thing to talk about: the median of trapezoids. Okay. You know what? We did the first example, the second, third example. Let's do the second example. I think this is the second example. It's kind of close to it, but yeah. So this is also a trapezoid because these two sides are parallel. But the median of the trapezoid is a line that goes through the middle of the trapezoid, and it's parallel to both of the bases, and cuts both of these sides in half. It's a median, right? But the thing is, the length of the median is the average of both bases. For some reason, that keeps popping up everywhere. That means this multiplied by the height should be equal to the area. And I made a little animation, a stop motion animation, because I couldn't completely replicate this on a keynote. Okay. So we start off with this trapezoid, right? It doesn't have to be an isosceles trapezoid. It works for any trapezoid, but this was the easiest one. So we have a median, right? This is the median. So we take the bottom part and we rotate it up, right? So that we have a parallelogram, right? Now, so this is the median, right? And this is also the median. So the length is 2 times the median. And this is half the height because the other half got moved over here. So this is 2 times the median times 1/2 the height, which is equal to the area. But to further prove it, we can cut this parallelogram now in half, right? So we have 2 parallelograms. And if we move this blue one all the way here, this is the median again. And this is the height. We have a parallelogram. And in case you don't know that the area of a parallelogram is base times height, we can take that side of the triangle and move it over there. So now we have a rectangle. That is the dimensions, the median by height. And the median is the average of both bases, which is the area of the trapezoid, and it makes sense. So there's the proof for you. Wow, that was satisfying. Okay, so what did we learn about trapezoids today? Well, we learned that they're quadrilaterals that have one set of parallel sides. We also learned about isosceles trapezoids and right trapezoids, and also, finally, last but not least, the median of trapezoids. Well, that's all I have for you today. Make sure to like and subscribe and put all your comments and questions and future topic suggestions in the comment box below. And see you next time. Peace.